solving radical equations, all right? This is chapter 4, section 7. What does this number right here, what is that called? The index. That is correct. Now, the index controls what we need to do to both sides. Because the index is a 3, you need to cube both sides of the equal sign. Because I cubed this side, I'm simply left with x squared minus 1. That's what gets rid of that cubic root right there. And 3 times 3 times 3 is 27. 3 times 3 times 3. 3 cubed is 27. Then you're allowed to add 1 to both sides, and you get x squared equals 28. Now you have to take the square root of both sides, but whenever you have an equation like x squared equals 25, x is technically equal to plus or minus 5. So this right here, x squared will equal plus or minus the square root of 28. But this is not simplified, so we have to break down the 28 that's inside of the radical.
That would be.
So if we break it down into a 4 and a 7, factors of 28, 4 times 7, we break down the factors of 4, which is a 2 and a 2. We can see, if we broke all of these factors down, we have a 2 times a 2 times a 7, but square roots look for what? Groups of 2. So this becomes plus or minus 2 radical 7. So our solution set will be plus or minus 2 radical 7. When you guys are doing radical equations, you need to take your answers and plug them back into the equation to see if they work. If they work, they're an answer, they're a solution. If they don't work, that's what's called an extraneous solution. And these will, both of them will work when you plug it in, because it says what? It says x squared. So what's going to happen to this negative 2 radical 7? It's going to become a positive. Okay? So your final answer for number 2 is plus or minus 2 radical 7. All right, number 3, let's look at it real quick. What's the index for number 3? 3. So once again, what do we have to do? We have to do what to both sides? We have to cube both sides. All right, once you cube both sides, what do you have left on the left-hand side of the equal sign? What do we have left? Well, on the right-hand side, you're right, we have negative 27. What do we have on here on the left-hand side?
7r plus 5.
7r plus 5, because by cubing both sides, it gets rid of this radical. What do we do next?
Negative 32.
So he's saying subtract 5 from both sides to get a negative 32. And then simply divide both sides by 7, and you get one answer and one answer only. And if you were to plug that in, it would work in your radical equation. So we have one solution set. I want you to keep it as an improper fraction, if you would please, and not a decimal. This is a more exact answer. All right, number 4 is a lot more difficult than the ones that we just did. Whenever you see a radical and another radical, my suggestion is to get the radicals on opposite sides of the equal sign. So I'm going to add the square root of 4x plus 9 to this side, and I'm going to add it to the other side. So here is what I have left. I have the square root of 6x plus 12 equals the square root of 4x plus 9, and then I'm going to add a 1 right here that's not underneath the radical, add it right there at the end. Our index, even though you can't see it, that's a 2. That index is a 2. So yes, you are going to have to square this side and square the other side. One of them is easy. One of them is more difficult. The easy one is right over here on the left-hand side. That just becomes 6x plus 12. On the right-hand side, if you are squaring this, you have the square root of 4x plus 9 plus 1 times the square root of 4x plus 9 plus 1. Now, there is a faster way of doing this without foiling it. Okay? But right now, for this purpose, I want you guys just to simply FOIL this out with me. We're going to take this right here, and we're going to distribute it to both numbers. And then I'm going to take the 1 and distribute it to both numbers. All right. This right here, the square root of 4x plus 9 times the square root of 4x plus 9 is simply 4x plus 9 because the radical times the radical, that's what it gets rid of it. Okay? Over here, though, I have 1 times the square root of 4x plus 9, so that's just the square root of 4x plus 9. Now I'm going to change colors. 1 times the square root of 4x plus 9 is another square root of 4x plus 9. And then 1 times 1 is simply 1. This right here, these are all of the products that we eventually have to add together. So let's see what we have. Right now, I have a 4x plus a 9. Now when we add these two together, right here, you have 2 radical 4x plus 9s. Not a very good x. Plus a 1. On the left-hand side, nothing's changed. It's still 6x plus 12. I'm just bringing that down. All right. We're going to scan the right-hand side of this equation. We're going to see if there's anything we can combine. I see a 4x, I see a 9, and I see a 1. Automatically, I can see that 9 and the 1 can be combined. So I'm going to put 4x plus 10 plus 2 times radical 4x plus 9. And now we come to the most important part of the process, and that's where do we go from here when we still have a radical that we're dealing with. All right? So in your journal right now, I want you to put a star next to this, and I want you to write, we need to isolate the radical. That's the most important part right now, is we need to isolate the radical. I'm going to highlight the radical so you know what I'm talking about. This part of the equation is the radical, and I need to get this part of the equation by itself.
You can subtract the 4x.
We're going to subtract the 4x, and we're going to subtract the 10 to isolate the radical. So I'm going to subtract 4x, I'm going to subtract the 10 on both sides, and that gives me the radical all by itself. 6x minus 4x is 2x. 12 minus 10 is 2 equals 2 radical 4x plus 9. Once again, you should notice that now I do have the radical isolated over here on the right-hand side. Now, fortunately, in this particular problem, I have a 2, I have a 2, and I have a 2, which means technically if I wanted to, I could divide everything by 2. So let's do that, make our problem even easier. I'm going to divide everything that you see by 2. Now this won't always happen. Sometimes that number will be a 3. If there's number 3 there, don't do it. Okay? So what do we have? We have 1x plus 1 equals radical 4x plus 9.
So if 4 stays the same, you're going to divide the 4 by 2.
No. We're doing 2 is, listen, 2 is, this radical is its own expression. We're just doing 2 divided by 2. So now that we're down to 1 radical equaling some expression, I want you to square both sides. We're going to take this side, and we're going to square it. We're going to take this side, and we're going to square it. Now, the right side's very easy. It just becomes 4x plus 9. This right here, everybody, I'm going to write down. This is what's called a perfect square trinomial. And there's a shortcut for perfect square trinomials that you need to know in your journal. So right now, in your journal, as an example, I want you guys to write perfect square trinomials. There's two rules. I have a plus b squared, or I have a minus b squared. The rule for a plus b squared is a squared plus 2ab plus b squared. The rule for a minus b squared is a squared minus 2ab plus b squared. This rule will work for anything that's a perfect square trinomial. When you're trying to square something, you can basically, all you need to know is what's your a value, what's your b value. Okay? And you can use these and just plug them in and get your result. I'm going to try to show you how to apply it. It's very easy. I have x squared. What's 1 plus 1? 2.
Oh, plus 1.
What's 1 times 1? 1. The shortcut is basically saying whatever number plus this number is, that's what's going to go here. And whatever number this is times itself is what goes down. Now we have a quadratic. And if we have a quadratic, what are we going to set it equal to? 0. So what are we going to do? We're going to subtract 4x, and we're going to subtract 9 from both sides. And now things are looking a lot easier. All right, everybody. Now we're down to a quadratic. And once you're down to a quadratic, there are multiple ways to solve this problem. You can factor this one. That's one way. You can plug it into the graphing calculator and watch where the graph hits the zeros. You can use the quadratic formula and do it. By the way, one answer will work and one answer will not work. One answer will, one answer won't. You can figure out which one works and which one doesn't.
How do we do the quadratic?
The quadratic formula, Ryan, is the negative b plus or minus the square root of b squared minus 4ac all over 2a. By the way, Ryan, in this one, if you want to do that, a is 1, b is negative 2, and c is negative 8. If you wanted to factor it, look for two numbers that multiply together to equal a number negative 8, and two numbers that add together to equal a negative 2. Now, if you wanted to factor this, okay, you're looking for two numbers that multiply together to equal a negative 8 and two numbers that add together to equal a negative 2. Those two numbers are negative 4 and positive 2. Because negative 4 times 2 is negative 8 and negative 4 plus 2 is a negative 2. So you write x minus 4 and x plus 2 equals 0. Which means, what number minus 4 equals 0? That number would be 4. And what number plus 2 equals 0? That number would be negative 2. So my solution set, everybody, is negative 2, comma 4, but only one of these works. Which one of them would work? Let me go back up to the original problem. We scroll up. If I plug in a positive number there, it's going to work. If I plug in a negative number there, it's not going to work. So therefore, we have an extraneous solution way down here. I'm going to say negative 2, you're extraneous. So our final answer is simply the number 4 is simply the only number